So good morning students. Today we are going to cover the artificial neural network in this series of application to soft computing. So my name is Professor Agwen Kumar Devedi, Information Technology Department, Kite Group of Institutions. So today we are going to cover the content of as an introduction part of ANN, the biological neurons part means where it is inspired from, the perceptron, what is a perceptron, artificial neural network architecture, the difference between single layer artificial neural network and the multi-layer artificial neural network, and the types of ANN part means the how a feed forward network are different from the backpropagation networks. So let's go in detail and discuss the things. So the term ANN is driven from the biological neural network. So when we think about the biological neural network means we are talking about the human brains, how our human brain works. So it's a combination of the sensors and the actuators. So as our body part, we have our tongue, we have our tongue to taste something, we have our skins to touch something, we have our ear, we have our nose. So these are the sensors, these are that takes input from the external environment. And there is some computational part, there is some computational node that process all the inputs instructions and again process it to the output actuators. So actuators are the nothing but the body part that performs towards external environment, means our hands and other parts. So these are the combination of, so how a human brain works means how it takes a signal from as an input from the sensors and how it compute with the help of some functions, and finally it pass it to the actuators. So what is the objective of ANN? Objective is to perform the various computational tasks faster than the traditional system, traditional machine learning algorithms that we have already covered. So these tasks includes classification algorithms. So students, we know what is the classifications, how a classification works, how approximation works, how optimization works. Means we have to perform something but in an optimized manner with the limited resources, with a limited time, with a minimum cost, and how clustering works, how the similar things can be kept together, how pattern recognition works, means where we get the some repetition manner with repetition patterns. So how NN can utilize in these linear and non-linear function. As we know, ANN can work in a both the way. We can perform some linear task as well as can non-linear task. So in the next slides we are going to discuss the biological neurons. So when we think about our human brains, it's just it's nothing but just a building blocks, and that is made up of four things. These are the dendrites, these are the cell nucleus, axons, and the synapse. Dendrites are nothing but the input entities that takes input from the external worlds. Cell nucleus perform all the computational tasks. Axons are nothing but a connecting mechanism that connects your inputs and the outputs. So outputs are synapse that gives output to the user. So as next slides, just a comparison between a biological and the artificial neural networks. So our biological terms are given like a dendrite, like a cell nucleus, synapse or axons, but our ANN part look like inputs. There would be some computational task as a nodes, there would be some weights corresponding to its inputs, and the finally outputs. So in this way we can compare our biological system as well as with the help of a artificial neural network. So then there is a terms comes like perceptrons. What is a perceptron? So perceptrons can be viewed as the building blocks in a single layer. So this is the single layer part where we have just input layer, we have a corresponding weights, and finally we are getting the output with the help of some computational task. So these are the components that create a one complete perceptron, a complete cycle. These are the input values, weights and the biases, net sum activation functions mean there would be some activation functions that will help you to calculate the output. So what is the goal of that perceptron? Perceptrons will compute the uh, process and finally obtain some inputs in the form of a boolean value. Either it would be a 0, either it would be a 1. So either you will get the true statements or the false statements. So it's finally a classification part, since ANN is known as for the classification model. So here we have a single layer ANN. So single layer ANN means we have an input set of inputs like input 1, input 2, input 3 and their corresponding weights, and finally we need to compute all the task with the help of some computational task and finally obtain some output. So there would be some equation or a formula with the help of we can finally reach to the conclusion or the output, and that formula is known as the Wi into xi plus b, where Wi means the number of weights we are getting here corresponding to the inputs value, that is known as an xi. So summation of Wi to xi plus b, where b is known as a bias, that would be a constant value. So if we'll apply Wi is a 0, our weights would be a 0, then we will not get the particular output. So there must be a constant value that gets a result in case of some default case even. So this is our single layer perceptron or single layer artificial neural network model. So in the same way we can have a multi-layer NN. So multi-layer means we are adding the multiple layer between first means input layer and the last one output layer. So in this diagram we are having two hidden layers. In the first hidden layer we have 3 different nodes, and in the second layer we are having the 4 nodes. So purpose of the hidden layer to calculate to find the hidden features and the patterns that we are getting in a complex problem. So as far as our task gets complicated, we'll need to add the more and more hidden layer to get the more and more and better result. So finally we reach to the types of ANN, means based on the categories we can divide our neural network into 2 parts. First one feed forward and the second one back propagations. So feed forward is a natural or a default neural network where perceptron moves towards the front direction. So in this way we have our inputs. In our early diagram we had corresponding weights. We are having computational task with the help of some activation function, and finally we reach to the output. So through assessment of its input by reviewing its output by reviewing its input, and the intensity of the network can be noticed based on the group behavior. Group behavior means the number of neurons we are having and the whatever the desired output we are looking for. So in the next one we can have the back propagations. So back propagation means the finally result where we are getting as an processed value, as an actual value, but what we were expecting. So there would be some expected value, and finally we'll get some error. So means we had some desired value, now we are getting the actual value. We are calculating the loss between the expected and the actual, and finally that error again need to be back propagated to the system. That system means the output layer to the hidden layer. If we have multiple hidden layers, then one by one all the hidden layer need to be processed, and the weights need to be rectified one by one, and finally in this way we can reach towards the input layer. So all the things need to be performed one by one in the back propagation layer. So students, in the next video we are going to cover the back propagation network in the detail. So thank you, have a nice day.